All right, guys, good morning. So if you're on track, it is May 4th and we are starting a new week, but it's a lot of the same kind of stuff. So here's our agenda for the week. We're going to be in Amplify today and on Wednesday. Tuesday and Thursday's assignments are in Google Classroom. They're based on Amplify stuff. I just modified them since we don't have partners to work with. And then Friday, like the last couple weeks, is going to be your learning block. Okay. Also, office hours today from 1 to 2. Nobody came to office hours last Monday. I sat here alone the whole time. Sign in, say hi. And then Thursday from 2:30 to 3:30. All right. Here's the link. All right. So today we're going to still be in 2.4, part 3. And then, of course, you guys can be starting to work on your learning logs as I grade the stuff. Before we get into the new assignment, I need to remind you where we left off because it's been a little bit. Okay, so in Amplify, we left off, we did part 2 last Thursday. And what we were doing is we were doing this. We got into the sim and we had our genetic material and we had it on laser and we turned the energy on. We were looking at what happens to the light. So we noticed when we did like anything in visible light, all that energy is just going through the genetic material. So that means it's not getting absorbed, right? What happened when we took it to ultraviolet? Am I on ultraviolet? Yeah. Ultraviolet, though, now the energy is no longer going through. It's stopping in the genetic material. And remember, our word for that was absorbed. And if we press inspect here, we had damage. Whereas when we saw that the light was just kind of going through, and I press inspect, nothing happened. So what we really noticed, we also notice infrared also stops in. So it is being absorbed, but it's not causing damage. It's causing heat. So this increased kinetic energy. When I went back to microwaves, it keeps going through. Radio, it's going through. Gamma, it's going to stop. But remember, gamma and X-ray don't reach our surface. All right. So what does this mean? All right. This looks like a lot, but it's not. All right. So the key concept there, which I don't know if we really understood last week, but we need to understand now. So a material, like we just saw the genetic material, absorbs energy from some types of light and not others. So what we noticed was all of the visible light, the microwaves, the radio waves, it doesn't get absorbed. It just goes straight through. The only ones that we saw got absorbed that we tested was the infrared and the ultraviolet. Okay. So what makes the types of light different? Well, we've talked about this. It's their wavelength and their frequency. So different types of light have different wavelengths. Remember, gamma, X-ray, ultraviolet, they have these short wavelengths, lots of energy. And so that's what's getting absorbed and causing damage. So it's the wavelength that's determining whether the light gets absorbed and what kind of change we see. We noticed infrared doesn't have a whole lot of energy. It's got this longer wavelength. It did get absorbed, but remember, it didn't cause damage. So then the other thing we need to remember is that wavelength and frequency are related. Remember, if it has a short wavelength, like these down here, then they have a bigger frequency. There's more waves. If they have a long wavelength, like the radio and microwaves, then they have a small frequency, less energy. So it all comes down to the properties of waves. All right, so we're going to use that information today as we do 2.4 part 3. So 2.4 part 3, and we are using evidence to make an argument about whether or not a light bulb can cause skin cancer. So we have two claims. Claim 1 is saying that light from the sun and the light from the light bulb can cause skin cancer. So that's saying that both can. Claim 2 is that the light from the sun causes skin cancer, but the light from the light bulb cannot. All right, so we're going to use the evidence here. They have some pictures for us to look at, but also don't forget, you can always get into the sim and try some things out and use stuff here, use like what we've already learned, right? So what this is showing us is that we have the sunlight on, and it's showing us what's in the sunlight. So we've learned the sunlight has gamma, X-ray, ultraviolet, visible light, infrared, microwave, radio wave. And we've learned that the light bulb only has visible light and infrared. So based on that information, what we've learned about these different types of light that these each have, which claim do you agree with? Do you think both are causing skin cancer, or do you think it's just the sun and the light bulb doesn't? Obviously, we're not going to do what your partner thinks because your partner's not here. So you can leave this one blank or answer it however you want. What I'm really looking for is these boxes, that they're done really well. So what evidence supports your claim? So give me specific things from these diagrams or things we've learned that support your claim of why either they both cause skin cancer or why is it just the sun that causes skin cancer. So make sure you're using the evidence. You can also use some of this key concept and what we've learned about like how someone's getting absorbed and it has to do with the wavelength. You can use some of this stuff too. Okay, then the next question, choose one type of light that causes skin cancer and one type that does not and explain why. So we've already learned what causes skin cancer, hopefully. So why does that cause skin cancer? And then pick one of the other types of light here that didn't cause skin cancer and explain why. So remember kind of what's going on here, right? So the ultraviolet, it goes in and stays, whereas if I change it to green light, it goes through and we don't get any change. So why does this happen? All right, so that is today's work. It's also all right here. And hope you guys have a great day. Let me know if you have any questions, and I hope to see a few of you in office hours.